Hi guys, today we're gonna be programming a very simple Arduino device that is gonna be using the ultrasonic sensors, which is by far my favorite one yet, and that is gonna be calculating the distance between the object and the sensors, and the LED is gonna switch on and off based on the distance. So in this project, you're gonna learn how to communicate between the Arduino and the sensor, and you will also learn how to send signals based on the data given by the sensor. So let's get right to it. So to make this device work, you're gonna need some LEDs, some jumper wires, a breadboard, and ultrasonic sensors, and Arduino. Of course, you can use any Arduino board you like, but I'm using the Arduino Uno here. And you will also need some 220 ohm resistor for your LEDs. Without them, your LEDs aren't gonna be surviving the 5 volt from the Arduino. Let's start by connecting your breadboard to the Arduino. For the red wires, it's gonna be 5 volt pin on the Arduino and the positive line on the breadboard. For the black wire, it's gonna be on the ground pin on the Arduino and the negative line on the breadboard. After that, we are gonna start connecting our LEDs. For the first LED, just connect to the pin 13 on the Arduino board, and for the other side, just connect to any of the horizontal line on the breadboard. It doesn't really matter, but make sure you have enough space for other LEDs on the board. You want to let the current flow through a 220 ohm resistor to the anode side of the LEDs. Every LED has anodes and cathodes, like anodes meaning the positive terminal and cathodes meaning the negative terminal, and current always flow from positive to negative as we know, so we just need to connect to the positive and cathodes to the negative terminal here. So it will be the ground here on our Arduino board, and that is one LED setup. And we just need to do the same for other LEDs as well, and connect the signal to the pin 12 and 11. Now that every LEDs that are connected to the pin 11, 12, 13 on the Arduino are all set up, let's take a look at the ultrasonic sensor. Now we can see that this sensor has 4 different pins. The VCC pin will be connected to the positive line, the trigger pin, which is used to release the pulses, will be connected to the pin number 6 on the Arduino, and the echo pin, which is used to receive the pulses, will be connected to the pin number 7 on the Arduino, and the ground pin finally will be connected to the negative line. So here's the final view to make sure that everything is connected properly. Boot up your Arduino IDE, because this is actually all we need to do for the hardware part, so we can actually start programming this thing now. So for the programming part, I'm gonna try to explain as much as possible. If you have some sort of programming background or knowledge, I think it's gonna help a little bit, but even if you don't have one, don't worry about it. This code is gonna be really simple. I think you're gonna be doing just fine. So let's get started by creating some variable. They're gonna be constant. Data type is gonna be byte. We need 3 variables for the 3 LED we have here. I remember connecting the red to pin 13, orange to pin 12, and green to pin 11. And we have 2 signal pin for the ultrasonic sensors. So echo pin was connected to pin number 7, and then trig pin was connected to pin number 6. So that's all the variable we need to assign right now, and then we need to set those pin up. So we can do this by typing pin mode in the setup function here. And to pin mode, inside this method you need 2 parameters. One is gonna be the pin number, the other is gonna be input or output. So we need to tell the Arduino what these pins are gonna do. So LEDs are obviously gonna be output, so we need red, orange, green, so they're gonna be output. And for the other two, the echo pin from the ultrasonic sensor is gonna be an input, so input, and the trigger pin is gonna be an output, because the trigger pin is gonna be releasing some pulse and the echo pin is gonna be receiving those pulse, like they all work together. That's why echo is an input, because it's gonna be receiving those pulse. And that's all the pin we need to assign. So after that we need some serial begin, so that we can output some stuff into the console. So in the loop, we want to set up the logic for the sensor. So how the sensor work is, you release some pulse using the trigger pin, like every 100 milliseconds you release some pulse, and after that the echo pins is gonna be receiving the pulse, and we can calculate the distance using the duration of those pulse. So we first have to turn the trigger pin off by typing low. So digital write is just like writing the pin, like high or low. It's just providing them with voltage, like low just means 0 voltage and high means it's providing 5 voltage. Since 5 volt was connected to these pins, so we will start with turning the trigger pin off, and we will add a small delay. Delay is gonna be 10 milliseconds, and then we will turn the trigger pin on by changing the low with high, and then add another delay which would be 100 milliseconds. It's gonna then stay turned on for 100 milliseconds, and then we're gonna turn it off, so it's gonna be low, trigger low. So now we did that, we just release a signal or a pulse, a sound wave from this trigger pin for 100 milliseconds. We need to capture that, so we can do this by using the pulse in method. So the pulse in method return an unsigned long variable. So unsigned long is the data type that's then method return, so we can just name it duration and do pulse in. Using the echo pin, we will turn that on, which means that the echo pin is gonna be on and it's gonna be receiving the signal that was just released here, and we are gonna be assigning the variable inside this thing, this duration, which is an unsigned long data type. And then this is just the duration. We need to turn this into a distance, so we can do this by using this formula, which is just duration multiplied by the speed of sound, which is at 0.034, and then dividing by 2. This formula will give the distance in the centimeter unit. So we are getting the distance with centimeter centimeter unit. So that is literally how the ultrasonic work. We already have the distance. We can do literally anything we want with this distance. So first, we will print the distance into the console, which is called serial in Arduino. Oh my god, what? Distance? Okay. Oh, don't forget the semicolon. Those are really important. Like your code won't work without those semicolon. The distance, you're gonna print those out. Okay, just put the unit here, cm. Now this is gonna work, but this is not doing what we want. We want to manipulate the LED based on the distance. So how we are gonna do that is, we're gonna use an if statement. If distance is less than or equal to 10 centimeter, then we want the red light to be on. So mean that if the distance is smaller than 10 centimeter, then the object is really close. That means the red light should be on. So we can do this by typing digital right, red, red, oh, what's going on? Red and high. Remember, high just means that we are providing it with 5 voltage. It just means it's gonna be on. Red is gonna be on. Nope, that's not what I meant to do. It's gonna be on. The other two lights, which are orange and greens, they are gonna be off. We can do this by using low. And else if distance is less than or equal to 20, then we want the orange light to turn on. So it's not that close, but still kind of close, so it's gonna be orange. And if it is farther than that, then we want the green light to be on, which would mean that the object is kind of far away, farther than 20 cm. Yep, this is all we need. We want to add a delay here, like 50 milliseconds will be fine. We do this to make the program a little bit smoother. Without this, it's gonna have like, it's not really that big of a deal, but it's just a good like practice to have this delay here. Like we don't want the system to be lagging, you know, like the output could be lagging, like we don't want that, so that's why this delay is here. So I think that is all. We can check if our code is correct or not by clicking this verify button. This will check for any errors. Let's see if I made any errors. So there is no red text, there is no error, there's no bugs. That means we just did it. Yeah, this is all we need to do. The code is working. We just need to upload this code to the Arduino machine, Arduino device, and we just need to test it. So let's do that right now. Okay, let's upload this file. All you need to do is connect your Arduino to your PC using the USB, and then hit this upload button, and it's gonna do a little bit of blinking light and stuff like that. Just wait a bit, and where is it? And there we go. Okay, it is working now. Wow, it's crazy. It is the default value is 404. The folder is detecting. As you can see, it is correctly detecting the distance. I'm using my keycard there, and the LEDs are correctly changing, and yeah, it is very successful. This project was very fun, I guess. I hope it's very educational for you guys too. I still can't believe the farthest object it is detecting is 404 centimeter away. It's iconic, oh my gosh. Alright, that's all for today guys. Thank you for watching. Hope you have a beautiful day. Peace.